All right, we're talking about how to find the slope, and right now we're just really talking about using a graph to find the slope. So remember, slope is a ratio. Slope is a ratio that measures steepness. Okay, and it's a very specific ratio. Remember, it's the rise over the run. The amount you moved up or down, or in other words, the change in the y value over the run, rise over the run. And so in the denominator, we're looking at how much did we run back and forth, how much did we change in the x direction, our change in x. So we need to find those two numbers in order to calculate the slope. So in our example here, if we're going to start at the point 2, 1, and we want to measure the slope, we're going to end at the point 4, 4, for instance, we would have to move up. In other words, we would have to rise. We'd have to move up 3 units, and then from there we would move to the right 2 units. So and go right 2 to go from one point to the other. So again, remember, when we're measuring the slope, we're going from one point to another, or anywhere on the line. Okay, the distance that we go up or down is our rise, and in our example we went up 3, so that number 3 goes in the numerator. And then we had to go to the right, which is our run, and that number goes in the denominator. We went the right 2. So our slope is 3/2 for that example. Now if we look at example 3, problem 3, we need to find the slope. That's the change in the y value over the change in the x value, rise over run. So you pick any 2 points on the line, and this example already has 2 points marked, and they have us starting at the point 0, 1, and we're going to move 1 unit to the right. That's a +1. Now, is that the rise or the run? Moving left and right, that's the run. That means our +1 would go, it's our x value, would go in the denominator. And then they went down, how many units? 1, 2, 3. So we went down, which is in the negative direction, 3. And that number goes in the numerator. Now, I suggest that, I don't like this example particularly. I would suggest that no matter which of the points you're going to start on, I would suggest always moving up or down first. Only because it helps us remember that that first number that we calculate goes in the first spot of our fraction, or on the top. So if I were going to do this problem, I might start at point 0, 1, right there, and I would go down first, -3, because that helps me remember that that's the first number of my fraction. So I go down 3 and then to the right 1. Does it make a difference in your answer? No. But if you get in the habit of maybe doing it that way, it's less likely that you're going to get your numbers in the wrong place. So I get in the habit of going up or down first and then back and forth. All right, let's look at example 4 now. Remember, slope is the change in y over the change in x, or rise over run. Doesn't matter what point you start with. I'm going to go ahead and start here at the point 3, 2. And I'm going to have to go down 2. So my change in y, or my rise, my numerator is -2. And from there, I'm going to have to cut all the way over here to the -4. And that's a change in the going left is negative. And how many spaces did I go left? How many units? I went 7 units. So -7 in the denominator. And you might want to clean that up again. Clean it up a little bit. -2 over -7. Negative divided by negative is just a positive. So our slope is actually 2/7. Now let's think backwards a little bit. Explain how you can use the point 2, 3 and the slope of 2 to draw a line. So now we're going backwards. I have to start with a point and a slope and draw the graph. So the first thing you would want to do is make sure that your slope is in fraction form. So how are we going to use the point 2, 3 and the slope of 2 to draw a line? First, we're going to make sure that our slope is written in fraction form. Now, why is this important to be a fraction form? Because remember, there's two directions as we move along the line. We're going to need to know how far to go up or down, right? And the numerator tells us that. And we need the denominator to tell us how far to go left and right. So we want our we want our slope to look like a fraction because we have two directions that we have to travel. All right, so then what do we do? The next step is going to be, we're going to have to plot this point. We need to know where to start on our graph. Okay, once we plot the point, then we're going to have to travel and find another point that's going to be on our line. And how do we travel? We use the slope to tell us what direction. We use the slope to tell us how far to go up or down. We're going to go up 2. And then how far do we go left or right? We're going to go to the right 1 based on our slope. So we're going to use the slope to give us directions. So in this case, we would go from the point 2, 3. We would go up 2 and to the right 1. So let's try one of these problems on the back. We're going to try problem number 3. Use the given slope, there's my slope, -1/2, and a point, the point 2, 4, to graph each line. So step 1, we're going to plot the point. Over 2, up 4. There's my point, the point 2, 4. Now from there I'm going to use the slope to tell me what direction to move to get to another point. Because my slope is -1/2, I can either write that as -1/2, which means I would go down 1 and to the right 2, or remember I can write 1/2. That also means -1/2. If I'm going to do that, then I would go up 1 and to the left 2. It doesn't matter which way you interpret the slope as long as you travel in the correct direction. So here we go. We're going to start at the point 2, 4, and let's use the slope with the -1 in the numerator. So if I start at the point 2, 4 and I go down 1 and to the right 2, alright, so I've ended up here at this point. That's the point 4, 3. So that means the point 4, 3 would be on my line. Well, let's just find another point on the line. Okay, let's use our slope written with -2 in the denominator. I'm going to go back here to my original point, and this time I'm going to go up 1 and to the left 2, and I'm going to have another point there. So now I have 2 points on my line. Now guess what? I could keep going. From here I could go up 1 and to the right 2 and get another point. Or if I wanted to, from this point here, I could go down 1 and to the right 2. I'm off the grid, but there would be another point. So you could keep going on forever if you want, but you really only need 2 points to draw a line. And you'd go ahead and get yourself a nice ruler, and you'd connect your points, and you would be able to draw a line. Whoops, that's not quite right. So, of course, you would do a much better job of it. You'd get it right on those lines. Okay, so connect the points, and that's how you would graph a line that has that slope and goes through those points. Oh, that's a little bit closer. You get the idea.